So we're branching out into different topics of interest. Please note that this is not a formal WHO meeting, and all of those who speak do so in their personal capacity. Please note also that this seminar is being broadcast over the web in real time and is being recorded for downloading afterwards. In order to get the best possible quality of this recording, may I ask you to please introduce yourself if you wish to intervene or ask a question, and to turn on and speak into your microphones. And those who are sitting in the back row, don't hesitate, but please come up to the table, turn on a microphone, and speak into it. Thank you very much. Dr. Summerhayes.
Yes, we're on. Thank you very much for the invitation to come to speak to you all today. It's a very great honor and a privilege to be here to talk about climate change, an emerging issue in health. I want to start with this slide, which is from the Intergovernmental Panel on Climate Change Working Group 2, which is the group that deals with impacts. That's the group that looks at possible health effects of climate change. And I thought you might be interested to see the little graph on the right, which shows where they expect to see negative impacts and where they expect to see positive impacts. I should explain that when they say with very high confidence up there, that means 90% probability. High confidence is 80% probability, and obviously medium confidence has a lesser probability. So let's start at the top, and with relation to malaria, you can see that the arrows point in both directions. That means that in some areas they expect a negative impact, but in some areas they expect a decline. There is high confidence that over time with global warming we'll see increases in malnutrition, significant increases in people suffering from death and disease and injuries from extreme weather events, and increases in the frequency of cardiorespiratory diseases from air quality changes, and also increases in the burden of diarrheal diseases. When it comes to things like the range of infectious disease vectors, again, we see that in some areas there will be a positive impact, that is that there will be a decrease, whereas in other areas there will be an increase. And because we're dealing with global warming, it's expected there will be a decrease in cold-related deaths. Not much of a surprise there. But we have to bear these points on the left in mind too. And that is that aside from the extreme events like hurricanes and so on, climate change is seldom the main factor in considering stresses on human sustainability. The vulnerability of human populations tends to depend very much on specific geographical and societal context. For example, the state of the development of the country that people are living in. And what we need to focus on more is their adaptive capacity of these populations, for example, to improve their supplies of fresh water, the infrastructure for their sanitation, and so on, so that the effects of these various climate-induced changes are minimized. Adverse effects clearly will be higher in the poorer countries, and access to water is obviously a key vulnerability indicator, and this includes both surface drainage and aquifers. Right, let's turn to climate change and talk a bit about that for a moment and look at the fundamentals. Well, the main driver over here is the sun, and solar energy pours down on the Earth and warms the surface. And what happens then is that radiation is emitted by the surface, but it's not the same radiation we get from the sun. Here we get a higher frequency radiation, and here we're getting a longer wave infrared radiation. And this longer wave radiation can be absorbed by what are called the greenhouse gases. Now these include water vapor, carbon dioxide, methane. They do not include oxygen and nitrogen. So the fact the air has got oxygen and nitrogen in it doesn't affect this. These gases can then re-radiate that radiation back towards the Earth or out into outer space, and that re-radiation is what helps to warm the atmosphere. It's jolly good that it does. Water vapor does an excellent job as a greenhouse gas in keeping us something like 33 degrees centigrade warmer than we would otherwise be if the water vapor wasn't there. The key thing, the key problem is not that we have water vapor in the atmosphere, it's that we're adding more CO2 and we're adding more methane to the natural methane and natural CO2 that was there in the first place. So continuing with the fundamentals then, the discovery was made in 1827 by this chap Jean-Baptiste Fourier, who first recognized the warming effect of these gases, and then along came Irish scientist John Tyndall, who actually measured the absorption of infrared radiation by both water vapor and carbon dioxide. The next key date is 1769. That's when this fellow over here, James Watt, patented the steam engine, because that led to the onset of the Industrial Revolution. So we began to burn coal and put carbon dioxide into the atmosphere, fine. And it was in the mid-50s, I suppose, that people started to wonder, what's the effect of this going to be on the atmosphere? And a fellow named Keeling was persuaded to start measuring the atmospheric carbon dioxide concentration, which he started doing in Hawaii on the volcano Mauna Lea. The reason is it's in the middle of the Pacific, it's a long way away from industry, and what that means is no local sources of contamination. Later on in the 2000s, we had some clever geochemists take the CO2 out of the atmosphere and shove it into a mass spectrometer to measure the isotopic composition of the carbon, and by doing so they were able to show that the air, the CO2 in the air, carries the signature not just of land plants and marine plants, but also of fossil fuel burning. So we have a very good idea that the carbon dioxide in the air, which you can see it increasing here from 1960 to 2010. This shows the carbon dioxide increasing. You can see it's a zigzag path, and that's because there is a seasonal signal superimposed on the carbon dioxide trend. But is this carbon dioxide the ultimate cause of global warming? Well, if you ask the Intergovernmental Panel on Climate Change, in 2007 they reported that they had very high confidence, meaning 90% probability, that we humans are increasing the concentration of greenhouse gases, CO2, methane, nitrous oxides, and that is making the temperatures rise. But that also means that there's a 10% probability that this is not the case, and you have to bear that in mind, although nobody has yet come up with a suitable alternative. This is the carbon dioxide picture, parts per million down the left-hand side. You can see that during the early years, 81,000 up to 1,700, that we had about 280 parts per million of carbon dioxide in the air. We know this because air bubbles got trapped in Antarctic and Greenland ice, and you can measure it. But there's James Watt, 1769, the invention of the steam engine, and lo and behold, immediately after that, the CO2 concentration starts shooting up as we burn coal and then oil to run our industries. Population is a significant multiplier, a force multiplier here. When I was a kid, just about 1950, the global population was only 2.5 billion. Now here I'm standing in front of you, and the population is darn near 7 billion. That's a tremendous rise in population, and over the next 30 years, we expect the population to go up to around about 9 billion. So this is what you might call a vicious circle for our times. More people obviously use more energy. More energy means more emissions. More people want to be affluent. Countries in Africa want to be like us in Europe. And more affluence means they want more gadgets, and more gadgets means more energy, and more energy means more emissions. So what we see when we look at the energy profile for the next 30 years, going from 2010 here, is that the projection is for more burning of coal, more burning of oil, and more burning of gas, with some increase in nuclear and renewables. So the demand is increasing, and we know where it's increasing. Here we see in the blue line, this is the OECD countries, more or less flatlined since about 1990, since about 2000. But the China and India together account for a very significant part of the projected rise in energy usage, and similarly the other non-OECD countries, their use is increasing. So we can see these increases going on, and the question is, what can be done about that? The consequences are here on this graph. Again, this is from the IPCC, and what we see is that the world is getting hotter. This graph here shows the rise in temperature from 1850 to 2005, and you can see the temperature is rising. Sea levels are rising. Here you can see the rise in sea level over that same period, and you can look at things like snow cover, and you see snow cover is decreasing. However, you see the coloring here, so it reminds us that this increase in temperature is actually very slow. It's 0.1 to 0.15 degrees centigrade per decade. Each of you would find it very difficult to measure that using an average household thermometer. Sea levels are rising very slowly at 3 millimeters per year. I doubt that any of you going down to the coast could measure a 3 millimeter change in sea level per year. So you have to bear in mind these things are very slow. The other thing we have to bear in mind is what's the difference between climate and weather. So here what we see from 1950 to 2010 is the zigzaggy trend of the global monthly mean in degrees centigrade, and you note lots of ups and downs. That's the weather effect. These are things like El Nino events. The El Ninos are the black here, and the La Ninas are the blue. La Ninas are cold events in the Pacific. El Ninos are the black ones. They're warm events in the Pacific. And you can just track this one here, which is 1998. Look up, great big warm event in the signal. And there's the corresponding La Nina down here, a cold event. And there you see it reflected in the global temperature, a cold event. So we know that there are natural fluctuations in the natural climate system which will cause variability. But equally, through that, we can project this trend. The trend is the trend of global warming. The trend is the overall climate trend for the planet, and that's what you have to bear in mind. What we can see also by looking at the temperatures for all the different years back to the 1850s is that the last 10 years, that's these dark colors over here on the left-hand side, 2000 to 2009, these last 10 years are all in the top 15 warmest years on record. And just to see 2009, there's 2009, it's 1, 2, 3, 4, it's the 5th warmest year on record, and the very warmest was 1998, which I showed you on the previous graph was a massive El Nino, a warm event in the Pacific. So we can see the planet's getting hotter, and we have been living in the warmest decade. Now, I'm not sure what the winter temperature here was like in Geneva, but in the UK, where I come from, it was very cold. It was also very cold across North America. And a lot of North Americans and Europeans were saying, well, if it's cold outside, surely that means global warming stopped. What you have to do is you have to look at the regional picture. So there's North America, here's Europe, that's Norway, there's the UK. And this blobby area here is where it was actually in January 1977, extremely warm and cold on either side. Now go to January 2010 or December 2009, the same picture. Very warm over Baffin Island. They had a record 7 degrees centigrade warmer than they'd had in previous years. Very cold in northern Russia and in Europe. Very cold in North America. This is because this is weather. This is the fact that periodically there is an oscillation, the AO, the Arctic Oscillation, which brings high pressure air down onto the Arctic, and that pushes the cold out to the margins, and there we see the cold air being pushed out to the margins, and it allows warm air to be dragged in. So just because we have a cold winter in North America or a cold winter here in Scandinavia and the western part of Western Europe, doesn't mean that global warming stopped. It is a weather fluctuation, and probably those of you who watch the Winter Olympics on television will remember that they didn't have enough snow in Vancouver. And that's because if you look at January, Vancouver over here was very warm, unusually so. It's not only warmth that's in the air, it's also water vapor, because when you warm the ocean, and all of these brown colors represent warming, you also put more water vapor. You get evaporation, so the water vapor goes into the air, and here you can see the water vapor rising along this curve. Warming causes evaporation, and water is a greenhouse gas. So you put water vapor into the air, and that's going to heat the air up more. So you have CO2 heating the air and water vapor, extra water vapor going into the air to warm it. And that's a positive feedback caused by the fact that CO2 warmed in the first place. One of the results is that we see the Arctic sea ice decreasing. So here is the sea ice during the summer of 1980, covering most of the area. And there is the sea ice in 2008. You see great areas of ocean exposed here. And the same applies to the winter. This graph here shows that the area of sea ice has been declining since 1978 right down to 2010 over here in this present winter. Less sea ice means that the ice is no longer reflecting back to space the energy that's coming in from the sun. And so that means that it's not cooling the planet the way it would normally do. Also, more exposure of this dark ocean means the ocean is able to absorb the sun's energy. So you've got two mechanisms, less reflection and more absorption, which means the Arctic is really warming up. And that warming up is helping to melt more sea ice. It's a really nice positive feedback. That's another vicious circle, which we otherwise know as positive feedback. We can look at the big ice sheets too, Greenland and Antarctica, and what we see there is that the amount of mass loss on the left-hand side from 1980 to 2010, we see it decreasing, and also you see from the curve in the arrow that the rate of decrease is increasing. So we're losing progressively more ice from the big ice sheets, both in Antarctica and in Greenland, and that's going into the ocean and helping to raise sea level, which is a message for coastal populations. Similarly, we can look at the glaciers on land. These are all of these different regions that have glaciers, Patagonia, the Andes, the Arctic, Europe, and you see only in one case, that's this one, in Europe, do we see some increase above zero in the glacier mass. And that's mainly because a lot of this comes from Norway, and warm, wet air is pushing up onto Norway and dumping snow there. But in most other places that's not happening. The global warming effect is causing the ice to retreat in land glaciers. That ice is also melting and going into the ocean. Right, so what can we do about this? Well, one of the things we'd like to do is to be able to model the way the climate behaves so that we can perhaps use these models to forecast what might happen in future. And this Japanese gentleman here, Japanese scientist by the name of Manabe, together with a colleague, in 1975 ran a model in which they doubled the amount of carbon dioxide in the atmosphere to see what would happen. And what they found was that down here, these are heights up from the ground, in what's called the troposphere, which is up to about 15 kilometers, they got warming, 3 degrees warming and slightly more. Whereas when they went up to where airplanes fly, up here above 20 kilometers, -1, -2, -3, they got cooling. So the troposphere warms and the stratosphere cools. This is a classic signal of global warming. They also, you will see here, note that for the polar regions, you've got excessive warming. So the warming in the polar regions goes up 4, 5, 6, 7, 8, even 10 degrees centigrade. So what happens if we look at what's really happening as aside from looking at a model? And here what you see is the actual temperatures. These are the different levels in the troposphere going from the surface to the lower, middle, and upper troposphere. And you can see 0.2 degrees warming per decade from all of these different agencies making the measurements. When you get up into the stratosphere, what do you find? Cooling, significant cooling. So the data verifies the model, and we're reasonably confident that even though the models are primitive, the fact that they can reproduce this means they're capable of telling us something about the future climate. I need to go back to that one. Right, so then there's the question, well, how do we know that it's human-induced? And this is a rather nice graph that shows in the dark color here, this is the temperature, the global temperature, zigzagging up from 1950 to where we are now. And you can put a more or less straight line through that. That's the trend, and these are the sort of weather-induced wiggles, El Nino events, and so on. These other three lines, the blue, the yellow, and this other one, which on the original slide was green, are zigzagging up and down also around a line that's basically flat. This is solar variability, and the zigzags are the sunspot cycles. There is an 11-year sunspot cycle, which you can see beautifully replicated here with the blue and yellow lines. Although the sun's varying like that, it's not going up. These values are not increasing. So we have a zero increase in solar energy and a massive increase in temperature. Would you like to explain this in terms of solar variation? Perhaps you would, perhaps you wouldn't. This is what carbon dioxide is doing. That's what the temperature is doing. This is what the sun is doing. What's the answer? Tell me when I've finished talking. Okay, well, why does this matter? Obviously, here we have the projections in global warming from the Intergovernmental Panel on Climate Change using various models and using different social scenarios. B1 is a scenario where the population peaks in about 2050 and where everybody's being good and virtuous and green and they're going low carbon, and so we don't get too much of an increase in temperature. Ideally, it stabilizes at less than a 2-degree increase by 2100. In the A scenarios, you have more population, you have business as usual, lots of energy usage, and you end up with temperatures up here. But you can see from the range here, if you take the bottom gray bar and the top of that one, there's something like about a 5-degree centigrade range. And it's difficult to predict with any certainty precisely where we're going to end up. But the reason for pushing for a low-carbon economy is that we would prefer to see us on a planet stay down here rather than end up here with an average of 4 degrees, which could be significantly bad for everybody. Let's now look at the next 20 years, because most of the people in this room will be still working over the next 20 years and looking at health problems, and so we want to know what's going to happen in the next 20 years. Well, here is the graph showing what's going to happen by 2030, and you can see from the very pale colors that the temperature rise over the next 20 years is not going to be probably just about up to 1 degree over most of the continents in which we have an interest. Not all that significant. The problems come when you look 90 years ahead, and then you can see from all these very dark colors that we've moved out into a world that looks like a very different planet, one where the temperatures are rather high. On the left, you can see the degree of certainty. So the pale brown curves there is for this one here, the middle one, and the lower one down there. And you can see that there's quite a range on these forecasts, from the low end, about ½ degree, up to the high end, 1.5 degrees. There is not fantastic certainty, and the certainty gets much less as you move into these higher end scenarios. These ones are the dark curves on the left, and you can see they're very broad. They range from, say, a 1.5 degrees in the B1 scenario right the way up to about a maximum of 4.5 degrees. So there is tremendous uncertainty in these future projections, and that you should bear in mind. But there are some things we do know. This is British Medical Journal for 2001, shows that people die when it's cold in the UK. Not a lot of difference between whether you live in a cold house or a warm house. In the summer, it doesn't matter. But in the winter, those living in the coldest of homes, more of them will die than will die in the warmest homes. However, the winter is a period when even if you're a warm home, there's a greater risk of dying. So we know that. We also can see that if you have the normal distribution of climate that we have now, and then you shift it to a new normal distribution, you will change things. So here's those poor people dying in the cold down here. They are now beyond the end of the new climate bell curve, so we don't have that degree of cold. That's good for people because that means less cold stress on populations. We have something over here at the other end, though. We used to have heat waves in this part of the bell curve. With the shift of the curve to the right, what that means is that this whole area, almost a third of the bell curve, now has the same temperatures that we used to regard as heat waves. And what they regard as heat waves for that future is an awful lot hotter than what we used to have as heat waves, real record hot weather. So heat stress is something that is likely to increase in the future. Well, if you look at the IPCC report, you will see they've addressed key impacts in various areas, and I'm just going to quickly run through these. Water is one, so we have water stress quite clearly. We have droughts as well. This is what Beijing looked like this week, from a Mongolian drought turning Beijing a nice orange color. And there are winners and losers. What we see here for 2100 is that all of the yellow areas are drought areas and all of the blue areas are rainy areas. So we see eastern China should get rainier, western China should get drier, the Mediterranean very dry, the Caribbean very dry, Peru, Chile very dry, Ecuador, Colombia very wet, Africa varied, the south and the north both dry, Kenya very wet, and so on. So we can tell where it's going to be perhaps better to live and where agriculture and water supplies will be stressed. We can also look at ecosystems. Here we can see with increased temperature you'll get coral bleaching. That could be very bad for fishermen who rely on fishes around coral reefs. The other big problem we have with putting carbon dioxide into the air is it gets into the ocean and makes the oceans acid. And this graph shows you from the sort of grayish areas that the oceans are beginning in some places to become more acid, very slightly more acid. If that continues, it could be a threat to the planktonic organisms at the base of the food chain that make their skeletons out of calcium carbonate. So we have a potential risk on the whole food chain for people relying on the oceans for food. Food, obviously, we have to consider cereal production. Down here at the 1 to 2 degree rise in temperature end, we don't see too much change. But we do see tendencies for cereal productivity at higher temperatures, 2, 3, and 4, to decrease in low latitudes, but to increase in high to mid latitudes. So Russians are very happy about this, and the Canadians are very happy about this, and even the northern part of the US is happy about that because they get to grow more grain. We know that droughts affect yield. This is a case in Zimbabwe. Every El Nino event brings low rainfall to Zimbabwe, and the maize yield drops off. So we can see already from Africa the kind of effects that water stress will have. With coasts, the problem is increased damage from floods and storms, but as we go through and get more and more warming of the ocean and more melting of glaciers, we expect significant coastal flooding when we get to fairly high global temperatures. This is why. This is from 1970 to 2010. This is the measured rise in sea level. The gray area is the IPCC's projection, and you can see that the actual rise is right on the top end of the IPCC's projection. When we look at their projections, we see that they're projecting an 80 centimeter maximum rise in sea level by 2100. That's almost a meter. But there are a number of scientists out there in the community who disagree with that, and they think that sea level is more likely to be in the region of 1.5 meters. Now again, I get back to my very slow phrase that I used earlier. That's only 1.5 centimeters per year, and you would find it difficult to measure. So it's not a tsunami. It's not an instantaneous catastrophe. It's what I would call a creeping catastrophe. If you did nothing about it for 100 years, it would be a catastrophe. But it's not a catastrophe tomorrow. It's not in the same league. However, if you didn't do anything about it, there are something like 150 million people living within a meter of sea level, and they certainly wouldn't be very happy with that sort of rise. These grayish areas here on the coasts of the UK and Denmark and Holland show you what would be flooded by just a 1 meter rise in sea level, and recognizing that in the UK they are going to be redesigning the Thames Barrier to withstand a possible further rise of 2 meters in sea level. There are other impacts on health which we looked at on that first slide, so I won't go into this in any more detail. I'm going to end up with a slide on that. But let's go back to malaria. We all know that when you have El Nino events in places like Colombia, it gets very wet. And lo and behold, malaria goes up and down depending on how wet it is in Colombia. And I showed you a graph just now of winners and losers, and one of the losers is Colombia, where it's going to get very much more wet, which means they may well get more malaria. We do know that one of the biggest impacts of global warming will be from extreme events, not the slow rise in average temperatures. So forget about the slow rise in temperature and focus on these events. And this graph here shows you the number of worldwide events from 1900 to 2007. The black ones are within the United States. The others are from the rest of the world. I have a problem with this kind of graph because it's not adjusted for the fact that we've seen massive population growth, and a lot of that population growth has been on the coast, in megacities and so on, and if you were to adjust for that, the picture might not look quite so disastrous. But we do recognize that with more energy in the atmosphere, these big events are likely to become more common. What we're really talking about here is what's called the tragedy of the commons. Nobody owns this resource, the air. More and more people want to use it to dump their CO2. So the value declines. Just as it declines on a commons with overgrazing or in the ocean with overfishing, it declines with global warming. This is a classic example of what's called market failure. So the markets are the problem here and not the solution, largely because the polluters aren't paying. And so we come down to the fact that regulation is likely to be the only solution, and we've seen it work in the case of ozone. The Montreal Protocol helped to close the ozone hole, or has helped to stabilize it and help it to close in the future. A lot of this comes from Joseph Stiglitz, the former chief economist of the World Bank, who's I recommend all of you to read Making Globalization Work, which is a very salutary exercise. We also need to think about energy costs. We are approaching what they call peak oil. This is 2010, and it looks like we've passed peak production. That means the price of oil will go up. That means effects on developing countries, which won't be particularly good. So the idea is, all right, this is where we're headed with energy use and CO2 into the atmosphere. This is where we want to be down here. And in order to get there, we need to become more efficient in energy use and use more renewables. You've heard all that before, I'm sure. One way to do that is to improve the cars we drive. These are, down at the bottom in blue, these are our conventional gasoline cars. The idea is to phase them out as much as possible and to replace them in due course with electric cars and H2 hybrid fuel cell cars. And already the Nissan factory in the UK started making electric cars. And to go from regular sources of energy to, for example, a lot more wind power. And I'm sure you've seen that kind of graph before. However, in the community in which I work, nobody any longer really believes that these targets are fully achievable to the extent that we would like. And so more and more we're talking about geoengineering, that is mechanisms to try and change the way the planet works. And this is one of these science fiction devices. It's an automated ship that sucks up water and expels it as droplets into the air over the ocean so that it forms clouds. And clouds reflect the sun's energy, so helping to cool the oceans. And I suspect we will see much more discussion about these things in the future. So my last slide, going back to this original diagram I showed you at the beginning, we have to recognize that the rise in warming is actually slow over the next 30 years. So don't expect any instantaneous change in health factors from that. We're not facing a health tsunami. We're not facing a global warming tsunami in the next 30 years. It's what I call a creeping catastrophe, and what we have to do is to plan for prevention. And that means these things down here. We have to encourage improved development, the ability of countries to get a grip, change the way they do things, and improve the way they manage themselves so that they can get clean water reliably, so that they have good sanitation, and also to develop low-carbon economies of the kind that we think we need planet-wide. And there I rest my case, and thank you for your attention.
Thank you very much. Does anyone have two brief questions for Dr. Summerhayes before we pass on to Maria Neira? Otherwise, we'll take them all at the end. Maria, then, would you like to? So this is the WHO counterpart, and the way these seminars work is that we have the invited external expert identified through the Wellcome Trust Institute for the History of Medicine. Sanjoy is here representing that institute, and he'll speak later about the development of the series. And then we have a response, usually from WHO. So here giving the WHO response, Dr. Neira, Director of the Department of Public Health and Environment. Thank you.
Thank you very much, and thank you all for attending this lunchtime seminar. I'm sure that you will be probably better at the cafeteria enjoying the lovely day, which is very warm today, but has not been the case until now. So I'm sure that you were not using that excuse to, present the controversy over the global warming. I think I will take from Colin and start to look at how the health community has been following this climate science, and more important than that, how the health community can help on pushing for this more sustainable development, or for these ideas of common sense that we are all convinced that have to be occur in the future. Let me start with something saying, is this really a controversy? If you look at this graphic, you can see that more than 90%, actually almost 97% of those who are specialists, climatologists, people who are publishing very often, all of them agree that human activity is a significant contributing factor in changing mean global temperature. So probably more of these controversy is in the public, the public perception, and is generated by the people who are reading newspapers, and probably they are not well informed, and we need to contribute to change that. Let's start. Once upon a time, 400 years ago, so this will take more than half an hour because we are starting 400 years before Christ, and we will go until 2006. So the climate change thing started. And in fact, I'm sure you will recognize Hippocrates. I hope you do. Working in WHO, I'm sure this is very familiar to you. He said that already. 400 years before Christ, he said, I told you, climate will have a great impact on health. Maybe he didn't say it with those words, but if you see, if you read what he said, you will realize that the health community has been very much aware of the impact of the climate and the weather in the diseases and the human health. Key dates here, and I think they were all in the last 30 years. You see, at the same time as we see a global temperature increase, we see some events and the way that WHO and the health community has been positioned. In 1990, we produced the first assessment on climate change and health, and then we started to produce other reports that you will see. We will we will review now in the next minutes. In the 1980s, health was supposed to be one of the 3 pillars of the climate policy. And I say it was supposed to be because they were putting health at the same level as economic and environmental impacts. But in fact, this was just on paper, because health was not really yet mainstream on all the climate policy and climate debate. And in fact, in 1992, when the UNFCCC described the adverse effects of climate change, they were using health, human health, and socioeconomic systems and ecosystems at the same level. But then later on, you will see that it was not exactly how these things evolved. In fact, in the first IPCC report, they were just a few lines about human health. But the health community were already moving, and this is when, at the beginning of the 90s, when WHO already published something that was called Potential Health Effects of Climatic Change. So don't think that WHO is just jumping now on a winning strategy or something that is attractive. WHO started to work on this in the 90s by publishing on a separate report, because we were not properly included in the IPCC, the first potential health effects of climatic change. In fact, later on, some tension emerged, and in fact it was because this graphic that you will see here, this map, they were predicting some changes that might occur with the global warming, and some of those changes were very attractive for the media, in the sense that, as you can see for the map, the data were kind of proposing that maybe the malaria transmission patterns will change in Europe. And of course, this was translated by the media as we will have malaria in France, we will have again malaria cases in Europe. So this was generating some controversy, and maybe even some disease specialists were reacting very strongly in saying things like, this is scientific Nostradamus, and this is not very serious, and just because the media and the evidence was not properly reflected by, the scientific evidence was not properly reflected by the media. But then in the early 2000s, we started to have a better description of the climate and the health links. This was produced in the early 2000s, and we, I think you all know Tony McMichael, who we have the privilege to have him a few months ago giving a lunchtime seminar as well. And all of those linkages are very complex, but we have now a better description, and I think finally climate and health links were properly established, and health started to be a little bit more mainstream in the climate policy. Obviously, if you want to be very pragmatic and empiric, you will look at this graphic from Lima, Peru, where you see that if you have 1 degree centigrade temperature increase, you will have an increase by 8% in the number of diarrhea cases recorded on a hospital in Peru, in Lima, Peru. So this is something very empiric and for us very concrete. Finally, in mid-2000, we started to put climate change and health more mainstream. And this is the way that the media was reporting this and proposing some press coverage in the 2003. And it's because climate change and health was included in the Global Burden of Diseases estimates produced by WHO in 2002. So it was considered among other health risks, and therefore somehow we started to have some figures, and those estimates were again very much attractive to the media because finally they have a number. They could say 150,000 deaths were caused by climate change according to the World Health Organization. Of course, in terms of raising awareness, there were some events that, some weather stream events that occurred in 2003, not necessarily linked to climate change, but they attracted a lot the attention of the scientific community again. Those two events were the heat event, in the extreme weather events in Paris, actually even in Spain, where I was serving at that time, and we were really in panic because the increase in the temperatures during the summer of 2003 was coinciding with an increase in the number of deaths of people in Paris, and that was attracting a lot attention of the media and the general public, and as well as the Hurricane Katrina, where again it was not linked to climate change, but clearly global warming was making this type of extreme weather events more likelihood. Now, let's look at the present, or including between 2007 and 2010. What's happened is that our Director General decided to raise the climate change to the more strategic and political agenda, and it was decided that the World Health Day in 2008 will be dedicated to climate change and health. And in fact, we call it, the campaign was called in 2008, Protecting Health from Climate Change. I think it was something extremely important. The DG identified climate change and health as a priority in 2007, and then very strong statements were made at different fora, which helped a lot to raise awareness about the health consequences of climate change. And then, as you probably know, in 2008, a very important resolution was passed, and it was a very important endorsement and very surprising and strongly support by all countries attending the World Health Assembly in 2008. As you know, normally there is controversy, there is debate, and in this case, the resolution on climate change and health, where ministers of health were asking WHO to take a more proactive role and engaging more on the climate change debate, it was approved with an incredible support. So now what we have is that WHO science on climate change is more applied and is across the regions. I'm giving you just some examples on how our regional offices are matching the commitment that was taken here in WHO headquarters, and they pass as well regional resolutions, and they decided on action plans. We have now several pilot projects going on adaptation, so we are supporting most vulnerable countries around the world on how they can adapt to the consequences on the health of the people that climate change is already having. And we were able to produce practical tools and training courses and guidance on how to assess the vulnerability of the countries and how can better propose to them. And another example, which I strongly recommend you to have a look at, is this document called Healthy Hospitals, Healthy Planet, and Healthy People, where we describe how the health sector can contribute as well to reduce our own carbon footprint, and by doing so, contributing to the health of the people. At the same time that the health community were moving and producing all of these events and reports and all of that, I'm sure you remember very well all of these big events and, by the environmental community. Of course, an inconvenient truth by Al Gore that was extremely important on raising awareness and attracting political attention and putting climate change very high on the political agendas. Then several reports, and I will focus on the sample of the Time magazine that was described here, where maybe we were going a little bit too much on the kind of apocalypse or catastrophe and disaster message. You know, Time magazine was saying, be worried, be very worried. And he was referring again to the possibilities of having malaria in countries where it was not present before. And then, you know, the Lancet, when this was jointly published with us, where they say climate change is the biggest global health threat of the 21st century. This was extremely important on raising awareness and attracting attention. But at the same time, as you know, human nature, we have a limit on the type of negative messages we can absorb. So probably this was generating as well a kind of sense of vulnerability by the people outside, say we need to protect ourselves, so all of those messages are maybe too much, and they started to relax a little bit. So in the meantime, health was still neglected in the climate discussions. Health was quoted in the first paragraph of the text of the proposed Copenhagen Agreement. I'm sure you all heard about Copenhagen last December. And in all the 41 of the less developed countries identify health as a priority within their national adaptation programs of action. So in principle, we should be very happy. We were going to Copenhagen with health very much as part of the climate change agenda, but in fact, health was mentioned only once, and then it disappeared. And then on all the National Adaptation Program for Action, although all the countries identify health as a priority, they got, the health sector, they got only 7% of the funding applications when they asked for money, and less than 1% of the UNFCCC funding so far has gone to health. And I say so far because we are working very hard on changing that. Then the Big Bang occurs, okay? All the head of states were in Copenhagen, all the international and multilaterals and NGOs and the big international community, we were all in Copenhagen hoping that a fantastic Big Bang will occur and the negotiations will produce an agreement. But I'm afraid we were not able to get one beautiful agreement right now, right away. Means that, okay, from now, from Copenhagen, where are we going? What do? We all have this feeling of failure and we simply cry and then go back and we try to raise awareness again. No, I think we have an incredible mission here to do and ensuring that Mexico will not be a failure, and something has to be done to avoid the terrible scenario that otherwise will occur. So how health can probably contribute to motivate this climate change agenda, how health arguments can be the motivator for engaging on more action. Well, we need to have a dream. And I think, you know, the big movements in the world, the big achievements were done because you were kind of proposing a dream to the people and stimulating them, inspiring them and telling them, we have a dream here, so let's move on something positive. I think on the climate change probably we did not spell out that dream, and we need to start to work a little bit more on a new approach on climate change and health. And the new approach is probably less on an environment, means I'm not saying that we will not focus on environmental issues, but probably telling the people that this is not just about the planet and about polar bears, it's about their human health, and it's about this generation, and it's about their daily lives. Probably we need to focus less on one single issue. We need to start to look at sustainable development. It goes beyond climate change. This is about the way we want to live in the next centuries. Probably less bureaucratic. I think Copenhagen demonstrated that there is no way to reach an agreement with 193 countries and the way the United Nations proposed. Probably less apocalyptic, and maybe a little bit more giving a human face to this climate change and the way we want to propose a new world, a new green development or green growth or new sustainable development, whatever we want to call it, but maybe a little bit more public health oriented, because we are convinced that health can be a very powerful driving force for the agenda. Maybe diversifying a little bit, concentrating the messages for the general population on the total benefits that we can obtain if we move in this new paradigm for development, more practical, definitely less bureaucratic. The system we put it in place in Copenhagen is not going to work. And then positive. We need this dream here. We need a Martin Luther King approach. We need leaders telling us, okay, we have a disaster in front of us, but this is what we are going to do. And nobody's taking us into that direction for the time being. So maybe health is the one. Some basic principles. Let's put health at the heart of the climate discussions. Until now it has been a lip service and everybody has been using health because it's attractive, but there is not a real engagement there. Then prioritize the no regrets preventive interventions. And I fully agree with your last slide where you were talking exactly about that. Climate is just one determinant of health, but in fact we know by now about many good deals and good interventions related to water, to sanitation, to basic public health interventions that are for sure no regrets intervention. No regrets in the sense that we are requiring the community to invest on something that in any case will produce very good and positive results. And then the third one, and I'm very pleased to see that even on the wording we agree, we need to take the opportunities to promote a healthy climate mitigation. Means that the health sector needs to describe what are the health implications of climate change. Mitigation, when you go on mitigation strategies, somehow you are promoting public health interventions, and this similarity needs to be better explained to the international community. In fact, for us, for the health community, responding to climate change is just a part of our preventive environmental health big agenda. And as you know, 25% of the global burden of diseases could be reduced if we have the common sense environmental interventions, and those are the ones that will reduce this burden of disease. Okay, we started with the inconvenient truth and the apocalypse now. Let's now move and look at the future. The future means that if we want to have a dream, we need to propose some very convenient truth. Number one means this is the chief of the administrator of EPA, Lisa Jackson, and she says something fantastic in Copenhagen that the health community, we were all, wow, so happy. She says, well, CO2 equal harm for health. Therefore, we will use the Clean Air Act and we will enforce that, and because it's bad for health, if we don't have an agreement in Copenhagen, it doesn't matter. We will do it because this is affecting the health of the people. So reducing CO2 equal bad health for the people. So, reducing CO2 equal health for the people. So let's reduce CO2 using the health argument. Wow, this is an argument. So we cannot agree more with that, and reducing CO2 equal health. Another very convenient truth. Adaptation to climate change means that the way the countries prepare to receive this damage, the negative impact that climate change is causing them, is basic public health. So let's make sure that we have additional funds, new funds, not the ODA funds that are diverted for climate change. No, new funds to help countries to better prepare, to be better adapted to the negative impact of climate change by reinforcing clean water and sanitation, vector control, disaster risk reduction, early warnings, humanitarian aid, which is the basic public health interventions. This is another dream, so another convenient truth that can inspire people. Third one, as I said, cutting carbon can bring direct health benefits. And this is the publication of The Lancet, again in collaboration with WHO, where we were looking at the health co-benefits generated by mitigation strategy. Means that when you take decisions on transport, for instance, you will reduce emissions, CO2 emissions, but at the same time you will probably facilitate that people will be able to walk in the cities, and therefore we will fight sedentary lifestyle. People, the air quality will be definitely much better, and we will reduce chronic and acute respiratory infections. So what else? Let's use this argument to move and make sure people understand there are health benefits generated from mitigation policies. And as Margaret Chan was saying, while the climatic effects of mitigation measures are long-term and dispersed through the world, the health benefits are immediate, and they are local, and we can quantify them and using them to motivate further action. So, health benefits from more sustainable living. As I said, sustainable urban transport. We could cut heart diseases and stroke by 10 to 20%, breast cancer, depression and dementia in developing countries. So, 30% reduction in animal fat consumption could reduce heart diseases by 15 to 16%. So, clean household energy. You know that we have every year 2 million people dying because the bad combustion and the fossil fuels that they are using to cook and at home. So this is unacceptable, and our agendas can be combined, and there is a lot to learn from that. The primary prevention means, let me tell you that before Etienne Krug and his colleagues will complain, of course there is a helmet in the head of the three people. Where is Etienne? Okay, we will put a nice helmet. Sorry about that. But this is the primary prevention. We increase physical activity, therefore we reduce obesity and depression. We reduce infrastructure cost. We increase social capital. We decrease cardiovascular diseases. We reduce CO2, and therefore we reduce air pollution. We reduce injuries. What else do you want? So it's really extremely positive. And of course, we put helmets because otherwise we will have injuries. Convenient truth number 4, health can show leadership, and we can lead by example. How? By greening ourselves. As you know, and I'm not talking about WHO. Of course, WHO, we need to green ourselves. But I'm talking about the health sector, from the very peripheral healthcare facility in Botswana to a very sophisticated hospital in Manhattan, or this hospital in Italy, in Florence. We can reduce our own carbon footprint. By doing so, we will do good for the environment. We will reduce our costs, so our hospitals will have money that they can use for other purposes, and we will generate health benefits. And this will be very stimulating for the health community. They love to be, showing commitment, and this is something that we are stimulating and inspiring now, and I think it can be part of this dream that Martin Luther King cannot help us, but we will try to put in place. The bottom line. No comments. I mean, I hope you can read it from here. Climate summit, okay? Imagine that we are in Mexico, and this guy is saying, what if it is a big house and we create a better world for nothing? So, I mean, we are talking about energy independence. We are talking about preserved rainforests. We are talking about sustainability, green jobs, livable cities, renewables, clean water, clean air, healthy children, etc., etc. So do you think, are we going in the wrong direction by supporting this agenda, or we are just trying to create a better world, but not for nothing, for a lot? Thank you very much.
Well, thank you, both speakers, for wonderful presentations. Learned a lot. I'm sure the audience gained a lot as well. I'm Sanjay Bhattacharya from the Wellcome Press Center for the History of Medicine at University College London, and will be moderating the discussions, which is always a pleasure. Can I just start off with two questions, one for each speaker? Colin, one point that Maria constantly made, clean water. Do you see a link between climate change and falling water quality, which might result in have a detrimental health impact, particularly in developing countries? And Maria, you raised a very important issue about funding, raising dedicated freestanding funding. But how do you achieve that as a senior WHO bureaucrat? I mean, isn't there going to be interdepartmental competition for funding? How do you transcend that problem? So thank you. And can you use the mic, please?
Yes. Okay, water. One of the problems with the, you remember I showed a slide showing the decline in land glaciers. Now the problem, let's say in the Himalayas, is that the glaciers lock up water and release it nicely for India and Pakistan and other countries in a nice regular manner through the year. But if the glaciers were to decrease by some significant amount, then that whole release mechanism would be possibly compromised. The same applies in the Andes for water supplies for Peru, for example. So the potential exists in this climate change picture for global warming to interfere with the mechanism of resupply of water to communities in these areas. And the other problem with regard to water supply is, depending on the extent to which sea level rises, that the rise in sea level in coastal communities can cause problems with the supply of water to coastal cities. So those are the.
Let me try to, not to answer, but to address your question related to the competition of funds. You know, our life in WHO is a permanent competition for funds, so I suppose we are all very well trained on that. Now, I don't think that the funds we need to use for this agenda should be the ones that we are already using for other, to address other health problems. I think those needs to be new funds, as I say, not coming from the classical ODA agenda. They need to be new funds for adaptation. I mean, the countries who have been polluting, they need to pay, at least for the adaptation agenda. And they need to do it on a very consistent way. And we need to make sure that the health sector will be well positioned, that those funds will start to be channeled. For the time being, there is a lot of talk about those famous funds and billions in the air, but they are in the air. Now, you made a very interesting point, Colin, when you say the way to solve this is about legislation. And probably you were talking about taxes without being politically non-correct. I think this is an issue that is on the table for discussion. Those who are polluting, probably they need to pay. How do we pay? Do we pay by carbon taxes? Each country needs to decide on that, or maybe it has to be a kind of international agreement. As you probably know, there is something called the Clean Development Mechanism that has already been established, and clearly there need to be new funds and new mechanisms for accessing the required financial sources. On the water issue, I wanted just to say one word on the work we have been doing with my colleagues from the Water and Sanitation. He's over there, but he's pretending that he's not listening to me. We just produce a book on, why you don't share the title of the document that has been produced.
Hi, I'm Chi Kyung from the Water Sanitation and Health Union. Yep, I think climate change is an issue that relates closely to the work that we've been doing over the past years. And recently we have developed a piece of work with Department for International Development of UK, DFID UK. The title is Vision 2030, talking about the resilience of water supply and sanitation in the face of climate change. So from the study, we hope to garner awareness and also influence policy on a shift towards giving a priority to factoring in climate resilience in the planning of water and sanitation infrastructure, and also getting the wider community at large to reassess the climate risks that they are facing against the existing water and sanitation infrastructure. And about how climate change will impact on water quality, definitely there's it is a huge dimension, and short of water, it means that the access to safe water is affected. So clearly, a shortage of quantity of water for basic personal hygiene that will invite a lot of health problems. And if on the other dimension, I mean to illustrate, if there's flooding issues, it means that there could be a spread of waterborne diseases. So all these are the climate impacts that could have a huge implication for water supply and also sanitation.
Questions, please, for the speakers from the floor? I think Najib? Oh. Sir, why don't you start and identify yourself?
Thank you. I was a little bit. I have a question to you, sir, about the.
Identify yourself.
Sorry, Derek Christie. I'm also in the same department of Public Health and Environment, Interventions for Healthy Environment. I'm just a little bit worried about the positive feedback mechanisms that you registered, and I think there may even be a few more. I was thinking about the methane in marshes, when the marshes melt and the methane escapes. I don't know if that's very important, but there seem to be quite a few of these, and the fact that the ocean's expanding and not only has more water in it, but the water takes up more space and other things like that, which leads me to my question: what is the real probability of what they call runaway warming?
That's a good question. We do see sea level rising not simply because glaciers are melting, but also because as the oceans warm, they expand. And right now the ocean is only warmed through its top 700 to 800 meters, and the oceans get up to 5,000 to 6,000 meters deep. So if you can imagine, if the sea level is already going up when you've only heated the top 700, that when you heat the whole lot, it's going to be quite significantly higher. And then you add into that melting ice from glaciers and Antarctica and Greenland, you have quite significant potential sea level rise. So that's one positive feedback. The one in the case of methane, this refers to the fact that the permafrost in the Arctic is trapping methane that's been formed from the decomposition of organic material in the soils, which are now frozen. And if you unfreeze the soils, if you thaw those soils, then the methane can escape into the atmosphere. And there is a fear that that will lead to a significant extra positive feedback and extra warming. The other thing we have to contend with, of course, is changes in land use practice. If you chop down trees, then trees are very good at absorbing carbon dioxide from the atmosphere. Whereas the grasslands that replace them aren't so effective. So changes in land use can have a very significant effect. If you add all these things together over the long term, then the possibility for extreme warming goes up. Not in the short-term time frame of the next 30 years, but probably in the longer-term time frame of the next 90 years. There is a possibility that there may be some more extreme global warming in the pipeline that we just don't know about yet. However, I tend not to play with these alarmist scenarios I think you have to be very careful in doing that, as you were saying. You know, we've had enough drum beating about alarmism. What we need now is to reflect on this and be pragmatic about the changes we want to make, and get them beginning. What we can do is we can go back to what the ice cores tell us. The ice cores have a nice record of climate change through the ice ages, which are not all that long ago geologically, and we can see from looking at the last, we are now living in an interglacial and a warm period. The last ice age ended 20,000 years ago. But if you go back 125,000 years, there was another warm period like today. And we know from that temperatures then were about 3 degrees more than they are now, and sea level was about 4 to 5 meters higher than it is now. So we have a good indication that if we keep warming, the geological record from ice cores is telling us what's likely to happen. Even if we didn't have any of these fancy numerical models, you could see from the historical data what's likely to happen. And now those don't really contain indications of what you might call runaway global warming. So I would rather say, let's look at the historical record, see what it tells us, and we know that we can get extreme change, but I don't think that it's telling us we're going to have runaway global warming.
Just first a comment. I think it's a latest UN report provided convincing evidence that we substantially contribute through our behavior to climate change. But that's not my question. My question is, what progress have we made during the recent years in reducing duty travel of WHO staff and thereby climate-relevant emissions? Is there any evaluation ongoing? WHO staff who reduced its duty travel substantially during recent years, and I'm working in the HR coordination program.
Thank you very much for this question. I think it's extremely relevant. I have here with me Dr. Roberto Bertolini, who is coordinating the unit, who is doing, among other things, climate change and health, and Marina Mayero from the same unit, who I'm sure they can address this question better than me. Not that I'm trying to escape. I just tell you what we have been proposing, and now some decision needs to be taken. Roberto, puoi dire sull'assessment?
Yes, Roberto Bertolini, Climate Change and Health in the Public Health Department, Public Health and Environment Department. Yeah, we did an evaluation of the total greenhouse gas, the carbon footprint of WHO, and out of the total amount of CO2 emissions, 75% is due to duty travel. The rest is building and water and eating and things like that. So now we are, making a number of exercises and scenarios to try to see which kind of proposals we will make to the Director General in order to limit this this quota of the greenhouse gas emissions. It's a quite complex exercise because then you need to to maintain the operations of the organization while decreasing the duty traveling or changing some patterns. You know that traveling by economy class, it's less impacting than traveling by business class. So there are also some issues of this type. So there will be an exercise that we are making now that we will propose different options, and then it will be up to the DG to decide. And this is part of a UN greater exercise to reduce the greening the UN, if you wish, as type of expression.
The SUN program.
The
SUN program.
The SUN program, I don't know about this, but it's okay. Okay.
Greening the UN, all the UN.
Well, I think the webinar system can help green the WHO because it allows new modes of meeting and discussion. Yeah. there was someone else. Carlos wanted to ask a question, and then the lady there.
I think it's part of the question of the money that I thought Maria was going to respond, but I think part of the money is being used in other sectors to do things that they are doing on an everyday basis. People do invest lots of money on transport, on energy, on housing, and actually some of the weathering or weatherproofing of houses, which are going to be done partly because of climate change, offer some very large opportunities for us in public health to include some of the public health advice and to include that as part of the developments in those sectors. So I think that's one area that we have some track record in WHO. We have some experience on that, on how to do those things. But I think that's one of the challenges that we have is actually to put that evidence much more to the use of those sectors, which in any case are much bigger than the health sector for a start, and where there's no additional costs for public health and there's enormous additional benefits. So some of that argumentation, I think, is a good part of the costs equation that you are raising, Reg.
Very pleased that Carlos is clarifying that, because I was referring more to adaptation funds, funds for supporting the countries at national level on their adaptation strategies. But when it is about mitigation, our role as WHO or as the health community will be to influence investments in other sectors by providing them with the good tools and the good arguments to produce health. So we will need some financial resources to produce those tools, but then the investment will be done by all of those sectors that will generate health benefits if we propose the right environmental intervention. So thank you, Carl.
Madam, and then we'll deal with the question from the webinar. Please, identify yourself, please.
My name is Teresa Garcia. I work in ITT, and I have really two questions. One for the first presenter. You chose in your presentation that there is a trend of temperature and warming and sea level rising, and I would like to know if that trend is accelerating. Are you calculating how fast does it grow? And for Maria, I work in IWA. We are experts in collaboration tools. So for the calculation and your recommendations to WHO, you may consider our tools. We do use it to communicate with staff in Kuala Lumpur, and that saves us a lot. Thanks.
Yes, in answer to your question about the trends, they each have a slight exponential tendency. So just as the energy use has an exponential increase built into it, so also the sea level rise and the temperature have an exponential tendency to them. Sea level rise, I think for the last century, was something like 2 millimeters per year. Now recent measurements suggest it's about 3.4 millimeters per year, so that's a significant increase.
My name is Marina Mayer. I'm also working in the Department of Public Health and Environment, and specifically I was responsible for the data collection for the carbon footprint exercise that we did in WHO. For your information, so far we've been using tools that UNEP has been provided to us within an overall exercise, the SUN exercise, the Sustainable UN program that we are collaborating to. So we didn't really explore any of the existing tools in-house. But thank you for actually raising this issue, and maybe we can take contact and
I'll be happy to give you all our contacts. Yeah, we are experts in that type of tools in-house. Okay.
Fantastic. Okay. Thank
you. Can I now direct Dr. Neira's attention to a question from Umeå University in Sweden on the webinar system. What is your view on the current state of the debate on changing infectious disease risks under changing climate? Will these risks still be an important mitigation argument in the Mexico meeting? And Dr. Neira, if you could use the mic, please.
Well, very shortly, I think all health arguments can be a very important argument in the Mexico meeting, but it will be very important the way we package those health arguments on, in particular for mitigation. We need to make sure that people understand that when they do mitigation, if they do prioritize certain mitigation strategies, they will produce more health benefits than when prioritize other mitigation strategies. All health arguments will be important to change in this debate. The evidence proving that certain infectious diseases pattern will change with the global warming, I think is already there, and is one of those arguments that have been presented together with all the science produced by IPCC to generate this political interest and the Copenhagen and now the Mexico. How and what will be the tonateur for this action that is required now? I think a good package of health arguments can contribute to that.
Thank you.
Perhaps I could ask a question of you. The IPCC reports have 3,000 pages. There are 3 working groups. Working Group 1 deals with the science, Working Group 2 deals with the impacts, Working Group 3 deals with mitigation strategies. And each of those is 1,000 pages long. And I was looking at the second one, impacts, which is where I got my information on health impacts from. And it struck me that health wasn't a very significant part of this volume. Now, right now, the Intergovernmental Panel on Climate Change is considering the assessment number 5, and I was wondering if WHO as an organization has any interest in upping the stakes and having more of an impact on the impacts volume for the next assessment.
Roberto Bertolini again. Yeah, I mean, there are two things happening at the moment. One is a volume on extreme weather events, which is being done as part of the assessment report 5. And at the moment, today, in Hanoi, there is a meeting, and one of our staff is actually attending this meeting. Another issue is the overall assessment 5, which at the moment the IPCC is recruiting experts for doing this. As you know, it's not very easy to get into this mechanism as an international organization. Usually the nominations are coming from countries. So we are trying to get represented into that process, but it's not given for granted. So, and we will interact in any way to try to get the health issue much more in this agenda. And we are trying to develop something as WHO to impact this development from the outside. Some sort of major review of the issue under different perspectives, under different angles, in order to influence the debate. You know, the IPCC works reviewing the international literature, the publications, what has been done, and therefore we would like to promote also this issue with an independent product that WHO can submit objectively, if not subjectively, to this process.
Madam, did you want to make a comment or ask a question? Can you please use a mic and identify yourself, please?
Hello, my name is Brenda Abha. I'm the IPCC External Relations Officer, and this is a question that was frequently asked to us from the media and also WHO. Why is that our section on health impacts, climate change impacts on health is relatively so small? And there's a very simple answer to this, which is the IPCC is not producing science. The IPCC is an assessment body. So the IPCC is only assessing the existing scientific literature available. In the case of impacts of climate change on health, this literature is very rare, little. And so that's one of the simplest reasons, which is given by the IPCC. There are not many literature on impacts of climate change, peer-reviewed literature on impact of climate change. I don't know if Maria has, but this is what the explanation we have. In fact, we don't have a lot of literature on that, and this is why the simple explanation that is given at the IPCC.
Before we go to another webinar question, I sense that Dr. Neira has a contrasting view to what has just been said, or do you agree about the lack of literature? Or?
Relatively. Compared to
I'm
other...
more comfortable with the relatively than non-existent, but I think there is a nice peer-reviewed literature that I hope that in this new assessment it will be considered. There is now a special issue of Lancet with a big collection of articles and papers, and we have been trying to continue the debate. So we will make sure this time that this available literature is not only available, but people is aware of.
Yeah, because
we do our best.
Yes, because health impacts, in fact, climate change impacts on health attracts a lot of interest, and especially in our developed countries. And so, yes.
Well, I'm delighted.
So,
sorry.
Also, funding for research in this area must be, I mean, is quite interesting, and it's an interesting area to explore, maybe.
No, I was about to say I'm delighted that you think the Lancet Commission report is something that is important to consider, because from a parochial view, I mean, UCL was deeply involved in working with your department in putting that together. We have another question through the webinar system from Natasha Sarkar, asking, apart from waterborne diseases, where else does the danger of climate change to health lie? Do projections target specific regions for the same?
Okay, very quickly, I think we can say that climate change will affect the most basic health determinants. I mean, water, food, and the air we breathe. So if those health determinants are affected, obviously our health will be impacted. Then you will have a direct way for our health to be affected, which are those extreme weather events that obviously will cause death and disability. And at the same time, we say that in WHO we say that the killing diseases, I mean those malnutrition, diarrheal diseases, and I'm missing the other one, diarrhea, malaria, and malnutrition, the three which are the killing diseases, are very sensitive to climate. Therefore, they will be exacerbated, those diseases. Essentially, what climate change will do, or global warming will do, is to exacerbate the existing health problems in many places. And obviously, those diseases that are vector-borne, if those vectors, they will have better weather conditions to reproduce, those diseases might increase.
Colin, please.
Yes, Colin Summerhayes, speaker again. One of the things that we haven't, either of the speakers mentioned, but I think has a bearing on health and is related to climate change, or potentially related to climate change, is warfare. Because if you recall the slide I showed that showed winners and losers in terms of water supply, there are going to be some very dry areas, much drier than now. There are going to be some areas that are much wetter. It's in the drier areas where there will be possibly fighting developing over water resources in particular. And it has been said that some of the conflict in Darfur today is actually related to the drying out that's going on there and competition for water resources. So I think this goes back also to a question about water supply. You know, we have to bear that in mind, that these external determinants can actually be quite important. They can change people's behavior, and warfare is something that could arise, and obviously will have a further detrimental effect on health.
We forgot, I mean, we didn't mention is the massive migration, the so-called climate refugees that global warming might generate associated to what you were describing, with all the health consequences.
Well, we did only have half an hour each, so.
More questions, comments? Please.
Derek Christie again. I was just thinking about we've talked quite a lot about the direct link between climate change and health, There also is, of course, the links that there are between sectors such as transport, energy, housing, waste management, land use, the way they have an impact on health and simultaneously on climate change. We've been thinking quite a lot about this, and how do you manage to intervene in this, what is basically a web. Everybody in epidemiology, politics, everybody likes to have a nice flow chart of A produces B produces C, and here we're really in a web. I think everybody's conscious of that. There are two approaches I've noticed over the past few years. One is the co-benefits discussion, which has been published substantially in the Lancet and elsewhere, saying if you do improve transport, energy, and housing, you will have co-benefits for health, co-benefits for climate change, and so on, and even co-benefits for economics, social aspects, and so on. The other tool, which we're really concentrating on in our unit, is something that's called health impact assessment. And if you do a health impact assessment on an investment or policy or program in transport or housing or land use or whatever, you can try to determine beforehand what sort of impact you're going to have on health. And it's not difficult to include the impact you may have on climate change. I think this is very important because environmental impact assessments are very common and have been established throughout the world. Whenever you have a big project, people tend to do, often it's a legal requirement, to do an environmental health impact assessment. Health is not necessarily included. Climate change is not necessarily included. So I'm wondering, and I'm not just wondering about it, there are lots of groups in the world already working on this, whether we can really bring together some sort of tool that will be accepted throughout the world that would combine the environment, climate change, and health. It would be some sort of prior assessment, but obviously it would have to be followed. There has to be a follow-up, and that's something that's been a big problem in the environmental thing. They usually say, well, we've got the stamp of approval, we've done our environmental impact assessment, and then they just go ahead with the project. So just to finish on that, I think if we could somehow bring together the environment, climate change, and health, it really would be a good thing.
Well, I think we both alluded to that in our separate slides. We hadn't collaborated beforehand, but we had the same message about the fact that you need development, you need infrastructure improvements, and so on. But let me give you an example from the Arctic. The Arctic Council, which is an intergovernmental body, has recently carried out an Arctic climate impact assessment, which was published in 2005. And the objective of that was to look at change in the Arctic in relation to the human populations, particularly reindeer herders, the Inuit peoples who live in the various Arctic environments, and so on, as well as the health of the animals that live there, polar bears and so on. The Arctic is a funny place because it concentrates pollutants from our various industries. So polar bears and humans have very high metal levels in their blood, and also levels of PCB much higher than those of us who live in Western Europe, for example. There is a concentration factor going on there. It's because the Inuit peoples are eating the animals that in turn have these very high levels of pollutants, that they're POPs, what are those? Persistent organic pollutants, that's right, yeah. And so they are actively looking at this, and I think what they're currently trying to develop is something called an Arctic climate scorecard, which will have various attributes that will be checked every year or every month or whatever they decide, so that they can see what changes are taking place and can make appropriate adaptations to that. So I think you are moving on exactly the right lines. We do need a monitoring system that identifies which are the particular threats and then develops a mechanism for us to assess the change in those threats one by one and the effects they have on the population, and to keep that marked and tick the boxes every year so that we can watch it happening and can take appropriate preventive or mitigation type steps. But in some places, as I say, in the Arctic, that's beginning.
Yeah.
Yes, I'm Maria Clark, and I'm with the Bulletin. My question has something to do with what you just asked, and it's basically whether or not there's, if either of the presenters could comment about the intrinsic difficulties of studying the relationship in terms of study design and generating good quality evidence, studying the relationship between climate change and specific health effects. Thank you.
Well, which of the speakers would like to start?
Roberto Bertolini again. Yeah, I think, you know, the issue is very, you are addressing the fundamental problem around this issue, because, I mean, we are facing for one of the first times not an evaluation of a risk which has already happened, and then we are simply quantifying it or identifying preventive measures, but we are assessing something which will happen. Therefore, I mean, there are scenarios involved. There are uncertainties about scenarios which add on top of uncertainties about the relationship between determinants and outcomes, on one hand. On the other hand, I mean, many of the issues we are facing are basically something that we know already, because the relationship between certain climatic conditions and vectors, or certain climatic conditions and diarrhea, or other type of things, or extreme events like heat waves or others, are known in the literature, and and also in the public health practice. So what we are seeing is an amplification of these factors. Therefore, there are some interesting formulas which have been developed in which you can see that, in fact, and these are links to the reasoning that Maria was doing of a no-regret type of strategy when you look at public health policy, that you add a multiplying factor on the existing relationship between certain determinants and health outcomes due to climate change. So that is one basic understanding that we have to do. So in terms of linking climate and health, there is no much question. The question is how the climate will influence the change in distribution of disease and the change distribution of determinants. And here we have the issue of scenarios and other dimensions which add on top of the existing knowledge an uncertainty factor due to the scenario themselves. So, I mean, so we need to be in this very difficult domain, but it's very important also in philosophical terms, because it introduces a new public health approach. Public health looking at future risks and preventing. I mean, somebody called that primordial prevention, meaning you are preventing not the exposure and disease relationship, but you are actually preventing the actual occurrence of exposure. So it's really a very interesting potential future for public health, not only applied to climate change, but also to other things like chemicals or other, exposures that might occur in the future. So I'm not sure I've been clear, but.
Yes, I was at I think the first WHO meeting where climate and health was discussed was, I think it was 1999 in London, and I was there, and it was organized by, I think, the British Medical Association, I can't remember quite. But one of the things that we were discussing, or that the audience was discussing there, was that in many instances the right data are not being collected. You know, there is a disconnect in government between the meteorological agencies measuring climate change and the health agencies responsible for healthcare. And unless you get these two communities together in each country and you start developing a set of, well, what needs to be measured in order for us to find out whether there is any link at all between climate change and health, you know, until you've got a mechanism for collecting the right kind of data, it may be that climate change is affecting health, but you just don't see it. The other thing that we observed was that, this is at that time, at the end of the last century, the amount of climate change over the last century was actually quite small. It was about 0.7 degrees centigrade. And that's an average, and we know that the Arctic was much higher. So when you take away the Arctic effect, the global, you know, what other countries were experiencing was less than that. And so when you have a globe affected by rather small changes, it's extremely difficult to separate the signal from the noise. And so there are places where the local change in climatic conditions for local reasons was completely swamping any global signal. So we know that there are these oscillations in the climate system. The Sahel, for example, is one where the Sahel migrates back and forth in relation to changes in the intertropical convergence that are driven by local climate changes, not by global warming. And so these, again, you have to take into consideration. So separating out local change or regional change even from what's a global signal is itself very difficult. And we need to bear all these different points in mind in trying to tease out what's climate change causing, what's this global change actually causing, as distinct from what's happening locally and would have happened anyway.
I know that this debate could go for hours, but and I agree with the previous interventions. Just to add that we need to be a little bit creative on the way we produce evidence on climate change and health. I'm afraid we go, as Roberto was saying, from climate change, how is the direct impact on health. That will be extremely difficult. But we know very well how air pollution is impacting health. So maybe we need to look at how the greenhouse gases emissions that are contributing to the air pollution in a city and how this air pollution is impacting health. So, as you say, it's a web, and we need to be a little bit creative on the way we will be producing this evidence. We know that drought will cause a problem with the food production, and we know that malnutrition is a problem for the health of the people. So again, we know very well what are the causes of climate change, and we can go one by one and see how this is impacting health, whether this is a direct assessment or is an indirect.
Well, we've gone beyond our allotted time, but I'm delighted to see that no one in the library needed the room today. But for me, it's a vindication for these seminars, to have seminars such as today's. I mean, I think this interaction between academics and policy managers, it can be useful for both parties. And I would again like to thank the WHO, especially KMS, for its support, the library for giving us the room, the Wellcome Trust for providing funding, and UCL, really. We have no nasty surprises. These things will continue for several years. So I think Najib wants to say a word, and thank you.
Thank you. Thank you. The Wellcome Trust and UCL for that, and for the audience. And actually, this subject is very close to my heart. I spent the first 6 years of my work actually in the WHO Center for Environmental Health Activities, where water supply, sanitation, air pollution, food safety were the only subjects that we talked about. And I learned all the WHO tricks actually through the environment and public health and how it affects the health of people. So I think this is a very important subject, and I was really impressed to see so many people here. So I'm grateful for your contribution, and thank you very much. Two commitments to make. We will continue this program regardless of anything, and we will continue to sustain it by the quality of the speakers and the program. And the other thing, we will change the room very soon to have another bigger room, because sorry, I came a few minutes late, so I did not have a place to sit, and many people. So we will find a much more bigger room and more convenient, because we think that this learning experience is what we need in WHO to continue and to build on the experience of people. So thank you for the audience, thank you for the speakers, and thank you, Sanjoy. Thank you. Thank you, Lara.